Okay, welcome back. In the last video, we simplified radical expressions, and this time we're going to multiply and rationalize. Okay, so when we multiply radicals, we have to remember, in order to multiply, they have to have the same index, and they both have to be inside the radical, or they both have to be outside the radical. Okay, so I can multiply this together because they have both are square roots, and they're both inside the radical, and I can multiply this together and simply get 15. Now, because both 3 and 5 were both prime numbers when I started, I don't have to simplify that, because if I try to simplify it, I get 3 times 5, I get no pairs. So this is my final answer, square root of 15. Okay? Now, for this one, I can multiply the outsides together. So 5 times 4 is 20. And then I multiply the insides together. So 2 times 7 is 14. Easy peasy? Again, I'm going to multiply the outsides together. Now, this does not give me I because this negative is on the outside. It's not inside the radical. We only get an I if it's inside the radical. So I get negative 1 times 4, which is negative 4, and then 3 times 6, which is 18. But wait a minute, I can simplify 18. So if I break this down, I get 2 times 9, which is 3 times 3. So I have a 3 that comes out. I multiply this 3 times this negative 4. I get negative 12 square root of 2. Okay? Again, I can multiply. You know what? I tell you what. I'm going to pause the video, and you guys do the next 3. Okay? All right. Welcome back. Because they're both inside the radical, I can multiply those together. And don't ask me what that is because I don't know. 5 times 5 is 25, carry my 2, so that's 75. So this is the square root of 75. But I know that I can probably simplify this. So I get 75, and then I get 2 times, I don't get 2 times anything. I get 5 times 25. What is wrong with me? I get 5 times 15. I just did that in my head. I get 5 times 15. And then I get 5 times 3. The 5's come out, and I have 5 radical 3. Okay, for this one, I multiply the outsides together. So that gives me 5 times, and then 6 times 30 is 180. And I'm willing to bet I can simplify that. So let's try it. So 180, I know that is 18 times 10. That is 9 times 2, 2 times 5. And 3 times 3. So who's going on the date? Those 2 are going on the date. Those 2 are going on the date. They come out. 3 times 2 is 6. So this is 5 times 6 times what was left? 5. So that's 30 square root of 5. Okay? For this one, again, we multiply the outsides together. So that's 15. We multiply the insides together, and that's the square root of 80. So simplifying 80, I get 10 times 8, 2 times 5, 2 times 4, 2 times 2. So how many 2's do I have? These 2 to go together, and I have these 2 go together. They come out as 4 because 2 times 2 is 4. So I have 15 times 2 times 2, and 5 is left. So I have 460 square root of 5. Okay? And now this last thing is something that math people like you to do. Once you get to calculus, we don't care if you can rationalize, but I think it's asked on the ACT, which is why we're teaching it here. All righty. For some reason, math people don't like the square root in the denominator. It's arbitrary. They just don't like it, so we have to get rid of it. So what we have to remember is that when I multiply, let's say I multiply the square root of 2 times the square root of 2, right? So we just noticed that if they're both inside the radical, we can multiply them together. That's going to give me the square root of 4. Well, what happened to that? That just became 2. So we call that rationalizing the denominator because it went from irrational to a rational number. Okay? And notice that when I take the square root of 2 and multiply by the square root of 2, I end up with 2. And we can see that for whatever. Let's say we have the square root of 3 times the square root of 3. we multiply that together, we get the square root of 9, and magically that radical just disappears, and I end up with 3. I can do that. Radical 8 times radical 8 gives me 8 times 8 is 64. The square root of 64, you guessed it, is 8. So we do this to get rid of the radical, to make it rational. That's why it's called rationalizing the denominator. Okay? So, to get rid of that radical in the denominator, I can multiply by square root of 5. But I cannot willy-nilly multiply the denominator by radical 5 without multiplying the numerator by radical 5. Okay? Because we can only multiply by 1. So this makes it 1. So remember, I can't multiply what's outside of the radical with something inside of the radical, so this becomes 2 square root of 5 over 5. Okay? What happened to the radical? Well, what happened to the radical was this was actually the square root of 25. And the square root of 25, it's a perfect square, so that's 5. Well, can I just cancel those two out? Nope, because this is inside the house. This is outside the house. People inside the house don't talk to people outside the house. Okay? So for this one, I'm going to multiply by the square root of 10 over the square root of 10 because I want to get rid of that square root. So I have 5 square root of 10 over the square root of 100, and the square root of 100 is just 10. And again, people inside the house can't talk to people outside the house, so I cannot simplify that. And yes, I know, I see I have a mistake there. That should be 10, not 100. Okay? Pause the video, see if you can't do that third problem. All right, welcome back. So this is just radical 2 over radical 2, which is people inside the house can't talk to people outside the house, so this is negative 3 radical 2. And radical 2 times radical 2 is the square root of 4, and the square root of 4 is 2. So now 20 can be simplified. As a matter of fact, all of these denominators can be simplified. So we can do it one or two ways. I think the easier way to do it is to simplify it first. So we have 20, 2 times 10, 2 times 5. This is 2 radical 5. So I have 2 square root of 3 over 2 radical 5. Now, these two can talk to each other because they're both outside the radical, so they'll cancel each other out. And then I'm going to multiply both the numerator and the denominator by 5, square root of 5. So because they're both inside the radical, I can multiply them together, so that's going to give me the square root of 15. And square root of 5 times the square root of 5 is just 5. So I have the square root of 15 over 5, and no, I can't simplify that. That's not square root of 3, because people in the house can't talk to people outside the house. All righty, let's simplify this. This is going to give me 8 is 2 times 4, which is 2 times 2. So we have 6 over 2 on the outside and 2 on the inside. Both of these are outside the radical, so they talk to each other, so I have 3 over radical 2. I still have to rationalize it, so I'm going to get rid of that radical 2. So now people outside the house can't talk to people inside the house, so this is 3 radical 2. Radical 2 times radical 2 is radical 4, which is just 2. Okay? Last one, we have 60. And breaking that down, that is 6 times 10, which is 2 times 3, which is 2 times 5. So my 2's are together. They're going to go out, and I'm left with 2 radical 15. So I have 4 square root of 2 over 2 square root of 15. Both of these are outside the house, so they can talk to each other. So I have 2 square root of 2 over the square root of 15. I rationalize that. I get radical 15 over radical 15. People inside the house can talk to each other, so these two can multiply together. I get 2 square root of 30 over 15. And that's all I can do with that, because I can't simplify that because people in the house do not talk to people outside the house. So that's the answer. All right, so that is multiplying radicals, and rationalizing radicals. So make sure you do your IXLs, and I will talk with you